Welcome to this course on engineering surveying and photogrammetry I. Surveying is one of the oldest and most fundamental branches of engineering. It provides the foundation for the design and construction of roads, bridges, dams, railways, and buildings. Without accurate surveying, no meaningful engineering project can be successfully executed. This course introduces you to the principles and practices of surveying, the equipment used, as well as practical methods such as chain surveying, compass traversing, leveling, contouring, and setting out works. In addition, you will gain an introduction to photogrammetry, which combines surveying with photography to produce maps and plans. The course is divided into two modules. Module 1, Principles, Equipment, and Classical Surveying Methods. Module 2, Advanced Techniques, Contouring, Photogrammetry, and Practical Applications. Let us begin with Module 1. Module 1, Principles, Equipment, and Classical Surveying Methods. 1.1 Principles of Surveying. Surveying is the art and science of measuring distances, angles, and positions on the Earth's surface, and representing them on maps or plans. The fundamental principle of surveying is that the position of any point on the ground can be determined relative to other known points. Key principles include: working from the whole to the part, major control points are established first, then details are filled in. Accuracy and precision, measurements must be as accurate as possible to avoid errors. Proper recording, field notes must be clear, complete, and free from ambiguity. 1.2 Surveying Equipment. Surveying relies on specialized instruments. Let us briefly discuss the most common ones. Chains and tapes, traditionally used for measuring distances. Chains are made of steel links, while tapes may be steel, linen, or invar for higher precision. Electronic distance measurement, EDM, modern instruments that use electromagnetic waves to measure distances quickly and accurately. Compass, used for measuring directions relative to magnetic north. Essential for traversing and orientation. Levels, used for determining differences in elevation. Types include dumpy level, tilting level, and automatic level. Theodolite, a precision instrument for measuring horizontal and vertical angles. Now often replaced by total stations. Ranging rods, painted poles used for aligning straight lines and marking survey stations. Abney level, a simple device for rough measurement of slopes and angles. Optical square, used to set out right angles on the field. Each instrument has its strengths and limitations, and surveyors often combine them to achieve reliable results. 1.3 Chain surveying. Chain surveying is the simplest and oldest form of surveying. It involves measuring distances with chains or tapes and plotting details by offset. Principles and method. The area is divided into triangles because a triangle is the simplest figure that can be plotted with accuracy. Baselines are established, and offsets are taken to capture details such as boundaries, buildings, and roads. Obstacles. Surveyors often face challenges such as rivers, buildings, or uneven terrain. These obstacles are managed by indirect measurement techniques, like using diagonals or auxiliary lines. Sources of error. Errors may arise from sagging or stretching of chains and tapes, incorrect alignment, carelessness in marking or recording, temperature and slope effects. Surveyors must always check and correct errors to ensure accuracy. 1 point for detailing by offset method. Offsets are lateral measurements taken at right angles or oblique angles from a survey line to the details on the ground. For example, to map the edge of a building or a boundary fence, perpendicular offsets are taken from the chain line. This method ensures that small features are captured accurately on the plan. 1.5 Compass traverse. The compass is used to establish directions and bearings. In compass traversing, a series of connected lines are measured, and their directions recorded. Orientation in surveying. Before beginning, the compass must be oriented with respect to magnetic north. Bearings are then recorded for each line. Adjustment. Since compasses are affected by local magnetic attraction from metallic objects or electric currents, adjustments must be made. Closing errors in a traverse are corrected using methods such as Bowditcher's rule. Sources of error: magnetic variation, instrumental errors, carelessness in sighting or recording. Despite these limitations, compass traversing remains valuable for reconnaissance and small-scale surveys. 1.6 Leveling. Leveling is the process of determining the relative height or elevation of points. Methods of leveling include simple leveling, direct reading between 2 points. Differential leveling, used when points are far apart or have significant elevation differences. Profile leveling, determines ground levels along a specific line, such as a proposed road or railway. Cross-section leveling, measures levels at right angles to the main line to capture terrain features. Reciprocal leveling, used across obstacles like rivers to eliminate errors due to curvature and refraction. Leveling is essential for construction projects, road design, drainage works, and earthwork calculations.